Okay, so today we got a little project. We have a clock out of a Corvette. I believe it's out of a 1960 something or another, or I don't know. It's pretty old. It belongs to Mike that lives next door of Mike and Stacy. You might have watched the video about removing Stacy's bush, and this is Mike's clock. So we're going to clean Mike's clock. Not really. We're going to fix Mike's clock. This clock goes in the dash of the Corvette, and it's a electromechanical clock. It has a spring and a mechanical device that will wind it up. It will make the clock run, but electrically it rewinds itself electrically every so many seconds. I think it pretty much equates out to about 1 minute. So every 60 seconds it resets and times down against a spring. I'm going to zoom in and we're going to see if we can't get a shot of the spring. Okay, we're going to focus or no? Maybe not. Might be a little too close to focus, huh? It'll focus right there. Okay. I get a little pointer or something that we can point with. Okay, so right here is a spring that actually makes this clock work. But more importantly than that is this relay right here that has a return spring on it right there. And when that relay pulls in, that's what actually makes this thing work, makes the spring work. So right here we have our positive terminal. This is where your positive side of your battery hooks up to. This metal strip around here, which is insulated by this piece of rubber, this is your negative. And the negative it's screwed down right here, and it's insulated with this piece of ceramic, or they have a name for this stuff, but I can't remember what it is. Anyway, because it's screwed down into here, the power flows on down through there and comes on over to this terminal. So when this relay pulls in, and we can push this relay in right here. When this relay pulls in, it sets the clock into motion. You can see that's starting to turn right there now. So come back around here and kind of show you what happens. When that relay pulls in, it pushes this arm, which pushes this over to there, roughly. Probably not quite that far, and sets it to going. And you can see the movement back here in the back, way back here on the back side. If you look down through there, you can see that movement turning. So every time that this thing pulls in, it sets this back and pulls that spring tight and starts to timing down. Then once it comes back up here and these two make, this sends a ground to the ground side of that relay and forces the relay to pull in, and then that resets it and it starts doing its thing all over again. I'm going to try to see if I can get you a little bit better view so we can kind of see what's going on here. I'm not sure if it's going to show up or not, but basically what's happening is the contacts are just wore out on this thing. So we're going to have to try to do something to fix them contacts in there. Okay, so I'm going to simulate what is supposed to be going on. Now, up here on the top, I've got, let's see, can't quite see it, can you? Readjust that a little bit. Alright, up here on the top, we've got a positive wire hooked up. And generally, this piece of metal right here, you see I just hit it and it actually worked that time. It kicked it out and it set the clock into motion, and the clock is actually working. Now we're going to let it go ahead and time down. It'll take about a minute, and when we start getting close to that minute, then I'll get the camera back up and running. Okay, we're coming up on the minute now. The contact's getting ready to close, and we're going to see if it's going to reset itself like it's supposed to. And it didn't. It stopped running. We've got the ground on there where it's going to be hooked up in the car, but it's not resetting. Now, if we cheat and we go over here and we touch it, we can make it reset. If you watch it close, here we go. There it went. So we just reset it. Now it's running again. So generally, the problem with these clocks is right here on these two contact points. The contacts get burnt and they won't make. Now, sometimes you can take a file, a small file, and file them a little bit, and they'll go back to working like they're supposed to. But most of the time, and I think in this case, I believe this thing is just wore slam out. But we're going to take a little closer look and see what it looks like. Okay, so I'm hoping this is going to turn out, but right there's supposed to be a contact, and as you can see, that thing is kind of concave. It doesn't look like there's anything there to even make contact. And if we go around on this side over here and we look at this side, I'm going to try to get the light on there. This side of the contact right here is fairly dirty, but it looks like there's right much contact on that side. That looks like a pretty good size piece right there. But the other side, I don't know, to me it looks like something's missing there. And we're going to see if we can't do a little something with it. Try to make something to go in there or something. Okay, so it looks like right here looks like a rivet where the contact point is riveted onto this little arm right that runs across here back to the relay. And I think what I want to do is I want to take that out. So I've got this little grinding tool and the Dremel, and we're going to see if we can't get that to come out of there. Okay, we're going to get a blower and we're going to get those filings out of there, and then we're going to try to push that rivet out the other side if we can. Hopefully it'll all come together, but I know my hands are going to be all in here, and there's no way that you're going to be able to see with me blocking that view. So I'm going to turn the camera off and then we'll get it back on just a second. Okay, so basically what we've done now is we've drilled a very tiny hole right where this rivet was, and we've took that piece that was in there out, and really wasn't much there. It just, the contact point that was in there was just burnt slam up. The other side is very concave where it's kind of gouged it out in there. So we're going to see if we can't make a new contact point to go inside of there. And the other contact point on up inside of here on this part of it seems to be okay. It's this one right here in the front that's giving us the trouble. Let's turn this over a little bit. There we go. So the one on the back side back here, this one, which is right there, that one seems to be, I mean, it's not in great shape, but it's in a lot better shape than what this one is. This one is more of the problem. So we're going to try to fix that first, see if that don't take care of the problem. So the first thing we're going to do is we're going to try to get a measurement of what this hole is. And that's a tiny little hole. So we're going to have to use something like, you know, maybe a drill bit that, and see what drill bit fits in there. This one right here fits in there, but it fits in there kind of loose, so we could use one a little bit bigger than that. And what we'll do is we'll find a drill bit that'll fit in there, and then we'll just mic it with this little small mic. It's a very accurate mic right here for doing jewelry work. And we'll mic it with that, and then we'll build a piece to go in there. Let me see if I can find some drill bits to stick in there. Okay, so we measured the piece we needed, and we came up with I guess the measurement because I didn't have anything that exactly fit into the hole. Anyway, guessed the measurement was 50 thousandths of an inch. So we're going to make this contact out of brass. I've got a piece of brass chucked up in the Craftsman Atlas lathe. And we're going to turn a stub down that's going to fit inside of that hole 50 thousandths of an inch. And the contact point for that thing should probably be 3 times that big, maybe. So 3 times 50 is 150 thousandths. So, you know, 150 thousandths, 200 thousandths, somewhere in there, I would think would be a good place to be. So I'm going to turn this piece down first to 150, 200 thousandths, and then we're going to turn it down to the diameter that we need it at. Sorry about the bump. Anyway. Okay. Now let's see where we're at. Okay, we're at 200. So we need to take off 75. Well, we need to go in 75 to take off 150. What we got? I think that's got it. I do believe that's got it right there. I believe that's got it. Okay. So we're just going to knock off that sharp edge. And now we got to part that piece off. And you're probably not going to be able to see this because kind of. And I really got this thing turning too fast to be parting, but you know what? It don't matter. Be alright. I was hoping I don't drop it down in there and lose it. So tiny. Alright. There it is. Right there. All we gotta do now is break that off. Well, break that off. Well. There we go. And then we'll just pile that tip off of there. Take it in there and put it in the vise and pile that off flat. And test fit it and see if she's going to go. Okay, so we got that little piece in the vise now. And we're just going to knock that little tip off the top. And let's see. There it is right there. And hopefully it does look like it fits in the hole right there, but it is right big. But anyway, we're going to see. What we're going to do is we're going to rotate this around here, and then I'm going to drop this down in this hole like that. And then we're just going to let it time down until it puts pressure against it. And then once it puts pressure against it, then we should be able to maybe solder it in place. Pretty big contact. Take a while for that thing to wear out. Alright, that holds it in place right there. Now all we got to do is get some solder on there some kind of way. Let's clamp it up in there. Let that hold it in place. See if we can figure out how we're going to get it on there. Okay, so we've got the soldering iron over here. We're trying to let it get hot. And then we're going to put it right up against here and let it get this hot. Okay, so we got that soldered on there. We got our electrical wires hooked up. We got it turned on. We're going to see what happens. And we're going to hope that this thing will make as soon as it touches. And there it goes. Now, the $64 question. I'm pretty sure, I'm not positive, but I'm pretty sure that the time that it takes that piece to get back up to this piece and touch that is supposed to be 60 seconds. Like I said, I'm not 100% positive, but I think that's the way this thing is supposed to work, but I don't know. Anyway, second hand is going around. We're going to find out. I mean, we'll just kind of see how close it gets and see what happens. It's timing down now. It seemed like it's taking more than 60 seconds for it to time down, though. So that may not be the case. It may be that it lasts longer than 60 seconds. You can see that second hand moving around, and you can see it's getting ready to close up here in just a few minutes, a few seconds actually. There it goes. And we'll count how many revolutions that thing goes around. Obviously, it's more than one. It's more than 60 seconds. So maybe that's not. Maybe it doesn't have to be tuned in to run 60 seconds, but maybe it clicks over every 2 minutes or every 120 seconds. Maybe even 3 minutes, because this is one right here. Okay, that's 1 minute. And we're coming up on 2 minutes. Okay, so it's a little over 2 minutes. Just a little over 120 seconds. So I guess the only thing to do now is just kind of wait and see if it keeps accurate time. I don't imagine that these clocks kept extremely accurate time. I don't know that to be a fact. I don't know. But anyway, electrically, we just, we got our positive right here on this terminal, and we just kind of grounded that little metal bar right there. Is what grounds that thing. Evidently, when it bolts up in there some kind of way, that grounds that other piece. So anyway, that this bottom terminal right here, it's not in too bad a shape. It looks like it's in pretty good shape. I actually cleaned it off a little bit with a small file, and it cleaned up pretty good. So I think it's going to be all right like that. That top piece that we actually replaced, this big piece right here is a piece that we replaced, and that was a piece that was worn the most, and it's soldered in there pretty good. There it goes. Fascinating how that thing works. Well, as always, it's nice to be able to fix something for a friend that might not otherwise be easily fixed. I think he told me you could send this thing out to a guy and he would fix it, and I think he said it was $100 to get it fixed. So it saved him $100. He said he was kind of getting crunched for money on this thing, on this Corvette project. So I try to help him out a little bit. They've been real good to me, and I always like to try to do more for others than they do for me. And that way I stay ahead of the game, and it's just a good practice to be in. Anyhow, I hope you enjoyed the video. If you've got a Corvette that the clock's not working in, chances are that's the problem. There's that contact right there. And not an extremely easy fix, but you gotta have the equipment to do it, But it's not extremely difficult either. It's all about having the right tools. Again, thanks for watching. Don't forget to rate, comment, subscribe.